A bacteria culture initially contains 1,500 bacteria and doubles every half hour. That's a key phrase right there. Doubles every half hour. So there are some biologists are throwing a group of bacteria into a petri dish, a culture of bacteria into a little petri dish. And initially there were 1,500 bacteria in the dish. And the number of bacteria, they're growing, they're reproducing, and they're doubling. The number of bacteria is doubling every half an hour. So half an hour later, there's 3,000, double. That's 30 minutes later. And then half an hour later, there's 6,000. This has been 1 hour total now. Half an hour later, there's 12,000. Half an hour later, there's 24,000. This is 2 hours later now. You see, you feeling the explosion? Keep going, double that, 48,000, 96,000. Basically, the next one would be like 200, because that's basically 100,000. 200,000. This is what? 3.5 hours later, 200,000. Then 400. That's 4 hours later. And then basically 800, 4.5. 5 hours, there's 1,600,000. This is exploding. Are you feeling it? This is exponential growth at its best. It's the population is exploding. This is what they this is what they mean when they say exponential growth. It's dangerous, it's powerful, right? Find the size of the bacterial, there's a missing C there, bacterial population after 80 minutes. Find the size after 5 hours. We just did that, didn't we? Anyway, let's do it with a formula. So what's the formula if they say, here's the key phrase, it doubles every K time? I'm going to give you a formula. If they say something doubles every K time, well, here's what you do. So we're going to say the amount equals P, the original amount, times 2 to the T over K. That's the formula you want to use when it doubles every K time. Where, again, the A is the amount later, like usual. P is the initial amount. Like money, it'd be like principal. It's the starting amount. The 2 is for the doubling, right? When you double, you multiply by 2, right? T, right there, T equals time. Okay, so that's the formula you want to use. So let's do it. So the amount is going to be P. What's the P? What's the principal? Initially contains 1,500. So that's the P. In fact, let me just bring it down here, probably better. So the P, 1,500 times 2 to the T over, what's K? K is the amount of time it takes to double. What's the amount of time? Half an hour. So what am I going to do? Well, basically, you need to do this problem all in the same time units. It doesn't matter what time units you prefer. Any of them are fine. You could do the whole problem in minutes. You could do the whole problem in hours. It'll work either way. It doesn't really matter. I think it'd probably be easier to just do it in minutes, because that way I don't have to convert 80 minutes to hours. I mean, I could, it's not the end of the world, but it'd probably be easier to convert 5 hours to minutes. You guys know that off the top of your head. 5 times 60, 300 minutes, right? So let's just go minutes. I think it'll be easier. It does, but again, I want to be clear. You can do any time unit you want. You can do seconds if you feel like it, or days, or weeks, or years. It doesn't matter. as long as it's consistent throughout the problem. You can't have part of the problem in minutes and the rest of the problem in hours. That'll surely mess you up. But just have it all minutes or all hours or all whatever you want. So I'm going to go all minutes. So a half an hour then is, as you know quite well, 30 minutes, right? Every half an hour, every 30 minutes. So the K equals 30 minutes, right? Because the amount of time it takes to double, it takes 30 minutes to double. So that's what you put underneath the time. You put that underneath the time. Do you see how this formula is going to work beautifully? You see, like, for example, what would happen if I plugged in for time 30 minutes? What would happen 30 minutes later? Well, that would be 30 over 30, which is 1. And 2 to the 1 is just 2. It'd be 1,500 times 2. 2 to the 1, just 2. It would double the 1,500. And that's right, isn't it? 30 minutes later, time 30 minutes, you should 2 to the 1, you should double the 1,500. See how that's working perfectly? There's our formula. Now, they're asking 80 minutes later. How much after 80 minutes? Well, then we just plug in 80. So after 80 minutes, the amount of bacteria will be 1,500 times 2 to the power of 80 over 30. So type that into your calculator and make sure, let me show. Make sure you type it in like this. So this is going to be 1,500 times 2 to the power. Then you got to parenthesize that 80 divided by 30. Why? Because that's all in the power zone. So whenever you have more than one item in a zone, now I've been talking to you about the numerator and denominator of a fraction, but now I can extend that idea to a power. Same thing. If you see how we have two numbers, we have an 80 and a 30, two numbers, both in one zone, so to speak, the power zone. So when you have more than one number in a zone, parenthesize it. That tells your calculator, oh, that 80 divided by 30, it's all up there in the power zone. If you don't do that, let me show you what it would do. If you just go, no, I'm just going to go like 80 divided by 30, like that with no parentheses. It will raise 2 to the 80th power, and then it'll just divide the whole thing by 30. It won't know that 30 is up in the power zone, you see. Whereas if you put parentheses, then it knows, oh, the whole 80 divided by 30 is all the power. So it'll do it right for you. And so when you get that, I'm getting the amount of bacteria will be 9,524. What do they want? They'll say, I mean, you can't really have part of a bacteria. I don't know, 0.4. I don't know what 0.4 of a bacteria is. It's just an estimate. Remember, math is made up. It's just estimating what will happen in the real world. So after 80 minutes, there will be about 9,524.4 bacteria in the Petri dish. It grew from 1,500 to 9,500 in 80 minutes. Now, how about after 5 hours? It's going to be ugly. After 5 hours, well, you got to change that to be 300 minutes, right? Times 60 minutes in every hour, 300 minutes. Use the formula, which is again P times 2 to the T over K. So the amount will be P. The principal, the starting amount. What was the starting amount? How many bacteria started? 1,500. 1,500 times 2 to the T. The time, this is the time. Time is 300 minutes. Over the K, what was the K? 30 minutes, right? Because 30 minutes was the doubling time. That's what K is. K is how long does it take to double 30 minutes? So there it is. Do that on your calculator, and it's going to be crazy. It's going to be the amount of bacteria in that little Petri dish is 1,536,000. There's 1.5 million bacteria in that Petri dish 5 hours later. So don't leave it overnight. It might go crazy. It might overflow the dish. So there we go. So so the key moral of the story on this problem is that whenever they bring up the issue, something doubles every whatever, doubles every 3 hours, doubles every half an hour, doubles every 20 minutes, whatever they say, you're going to use the doubling formula. So that is A equals P2 for doubling to the T over K. T is the time, K is the amount of time it takes to double. So this becomes 1500 times 2 to the T over 30, because we're starting with 1500 and 30 is the time it takes to double. So then we plugged in 80 minutes right there, got an answer. Then we plugged in 300 minutes right there, same formula, got an answer. So that's how we handle it when something is doubling in every period of time. It's exponential. See how the T is up in the power zone? And it's powerful. It blows up to 1.5 million after just 5 hours. There we go.